Please, I hope we remember that when we set an initial value to 0, so we say total equals to 0, then we come and write for each of the items. So let's say for revenue in daily revenue. Okay, so then we say that revenue total equals to total plus revenue. Okay, so we did that, and then Python will iteratively go through and add these values incrementally. So by the end, the loop comes to the end of the last value. We will realize that all these items will be added. Okay, so that is how we implemented it manually. However, Python has an inbuilt function calls the sum. So the sum, which is a function, when you put the any list as an argument, will add the values within the list. So let's see that in real action. So we have this particular list of items, which is daily revenue. We want to see the total daily revenue. All right, so when we run this code, you see that Python has added these values without rewriting the for loop ourselves, but it uses this sum function. And the truth of the matter is that what this sum function is doing is that it implemented the iterative code that we learned initially. Okay, so meaning that if you know that iterative process and you understand it properly, you can also write your own functions. All right, so that is that for the sum. So if anytime you want to add all the values within a list, you can just use the sum, provided you don't want to write a for loop to add all the values. You just write the sum, then you go. And I'll always prefer that. Easy is, simple is always good. So instead of going to write a for loop for it, you can use a sum. But however, you can also test your skills since you are now beginning to see whether you can also write what actually this function is doing. That is adding the items within the list. Okay, and also we can also figure out the minimum. Okay, so the minimum, use the main function. So this is the syntax. You write the main function with your brackets, and then you pass the list to it as an argument. So once you do that, it's going to give you the lowest value in the list. And this one, you can write a for loop for it, whereby you use an iterative process and you set an initial value. So if this value is greater than this, ignore. If this is greater than that, ignore. So you iterate through them, okay, recursively. Then by the end of it, you realize that Python will be able to return the minimum value. Okay, so you can even give it a try, whereby you write a for loop to figure out what is the minimum value within a list. However, if you don't want to do that, it's perfectly fine. You can use the main function to return any minimum value of your list. Okay, so I think these ones and the maximum, no explanation, is self-explanatory. Returns the maximum value. Okay, so here is just a printout. So we have the maximum, whereby we use the max and the minimum and then the max. Okay, all right, and here is a range. So here we say that max glucose reading minus mean glucose readings, which gives you this. Okay, and sorry, which gives you the range. It gives you the range, and then this one gives you the max, and then also and also the minimum gives you the minimum value in your list. So that is that. So we can compute the average using the sum and then the len function, and we already know the len, that it returns the number of items within a particular data structure. So in this case, a list. So when you want to calculate the mean, which is the average, it goes to the sum, which is sum. So sum will add all these things divided by the len, which is the length of all these things. So it makes it very simple. So you calculate it and you use the round function to put it to 2 decimal places. So you have that because it has only 1 decimal place. That's why you don't have the 2. But provided it's more, it will truncate it to 2 decimal places. Okay, so I think we have another one here. Okay, so another function that we can also use is the sorted. You remember that when we were doing list, we used something called the dot sort function. Please, do you remember that? I guess we do, right? So the dot sort, when we were trying to sort the item, we can note between the sort method. This is a method, and actually this is a function. So the dot sort method actually changes the values within this particular variable. So in this case, we have assigned A to the values 9 to the list 19 to the list of values 19, 2, and 45. So when we say B equals to A dot sort, it means that we are performing the sort on the values of the A. Okay, so this means that the values of the A itself will change. Let's see that in action. So you see that when we run B equals to A dot sort and we run A. Now we assign this A dot sort to a variable called B. Okay. But however, when we printed A, you can see that the values within the A has been sorted. Okay, so what it means is that, or what it implies is that, the sort method actually changes the values, the order of the values of the list of the original um, variable that you created. However, when you use the sort function, it creates a new function altogether. So let's run this and see. So you can see that here we run the sorted function on the list called A. And when we call the A later, we realize that the values of the A are the same, they have not changed. But when we use the dot sort, which is the method, the values of the A changed. So here, let's print the B and see. Okay, so once we print the B, you can see that the B has been sorted, but the A has not been sorted. But here, let's print the B and see. So, um, okay, let me just run it. It has written now. Oh, okay. Um, okay, actually, I was not expecting this behavior, but it has written none, meaning that it does not know. I mean, this is an empty something. Okay, but however, you can see that. I mean, what I want to pass across is that when you use the dot sort method on any variable, the values of the variable changes. But when you use the sorted function on any variable, the original values of the variable does not change. Okay, so maybe you would like to know when to use them. Maybe you don't want the actual values to change. You just need to assign, you want to assign a sorted value to a new variable and work on it. That one, you don't have to use the dot sort method on that particular variable since it will change its original values. However, you will use the sorted, which it will not change the original values. But however, it is going to modify the values that you have into a new list, which is which has the effect that you want or you like. Okay. All right. So with that said, let's see that one in real action. So you have scores over here, which we would like to sort. Okay, so rank scores equals to sorted scores. Okay, and then the sorted can also take some other argument, which is the reverse true, when we want to return the values in a descending order. So let's see how it works. All right, so the original value is this. Okay, ascending order, when we run the sorted, it arranges it in ascending order by default. So you have that. And then when we use the reverse equals to true, it it's it arranges it um, in descending order. Okay. So I mean these are just some functions that are easy to understand. So let me make progress on that. So we have the any and all. Okay. So any returns true if at least one item in the list is true, and all returns true if only if every item in the list is true. Okay, so maybe you would like to figure out, let's say, whether the values in the list meet a particular condition. So you can use any. And how we understand any in English language is the same thing, and all in English language is the same thing that Python does. So let's see that in with the raw data. So we have exam scores, which are data of students, and then we say that failures equals to. So we have a less comprehension here. And then less comprehension says that score less than 50 for score in exams. So in a typical for loop, it's going to be for score in exams score, which is this values for each of the items within these values. So maybe return, or you're going to print score less than 50. So this is actually a condition. Okay, so if it checks for each of the values over here to see whether it is less than 50, if it is not, if it is less than 50, it's going to give you true. If it is not, it's going to give you false. So the list of the failures is going to be true or false, true or false. Let's see that one in action so that we can appreciate the outcome. So let's print the failures and see. You get it? So we have true, false, true, false, true, false. Okay, but before I continue, who can explain this behavior? Why is it that here we are having true, true or false within as values of our for each of them? And we know that conditional, when we're doing Boolean operators, when you have a Boolean expression, the outcome is true or false. So you pick this 78, is 78 less than 50? The outcome will either be true or false. Okay, so that's why we have true or false over here. Okay, so let me just take this one out and then. Okay. Okay, so now that we have that, we are going to print failures and then flag them. Now let's look at here. We are saying that has failures equals to any failures. So what the what the any failures will do is that it checks through your list over here, which is this one, the true or false, and then check if any of them is true. That is, if any of them has this condition, which is actually a true, which if any of them meet this condition. Please, you get it? So let me run it and let's see it in action. So here we had true or false, true or false, true or false, and then we know from here that the any returns true if at least one item in the list is true. Okay, so which of the conditions? So when we run these conditions on the items within the exam score, did we find true? Yes, there was one true. So if we say that any failures, meaning that is any of the items or the values less than 50? Yes, true. So when you run any failures, it's going to return true, giving you a fair knowledge that, oh, this item actually has a value less than, the list has values less than 45. Okay. All right. So this can be crucial in data analysis. Maybe you want to figure out whether your data contain any missing number. So here, instead of failures, it's going to be any missing number. Then has a missing number. What then can I do with it? Okay. What methods can I implement to remove, whether to remove it or to replace that missing number, and a particular error or a particular condition is found. So maybe you can have the data and then maybe you're not expecting some values. Okay, so you can run any on that column to figure out, does this column contain any unrealistic value? When it returns true, then that is going to tell you that, oh, it contains. So now you're going to search for that value. So in this case, here that we found out that, oh, there is a value that is less than 50, which is true. Then we can say that, okay, let us print all values that are less than 50 in the list. Okay, right. So let's try that and see. So in this case, we are going to write a code that is going to retain all values in the list that are less than 45. Okay, with this, I would like someone to, give it a try. How can we implement such a code? What is the first step? All of us. So let's solve it together. I don't want to be telling you that at least we are all learning together. So let's try to put things together. Let's cook something right now. So how do we return? We have a list here. We know that there are some of the values which made this condition less than 50. So we want to know those values. So what are those values? How do we write? Which Python code are we going to use? Which method approach are we going to use? Okay, so the question is that now we've realized from this any function that we run that there are some people, some scores within the exam scores of the students which are less than 50. So we know that some are there, but we want to know them. We want to know the actual values. So how do we get to know them? How do we get to know the values within the exam score which are less than 50? How are you going to do? Just giving me the full code. And maybe you thinking about it, what we've learned, loops, if statement, less comprehension, data structures, everything. Putting it together, what do you think we should use? Which tools? Now you have tools in your garage or in your cabinet. You want to solve a problem. Which tool are you going to use? So that's how programming is. So you have a lot of tools. So you have a problem. You have to go for the right tool to solve the problem. So in this case, for the sake of time, we can use a for loop. So we use a for loop to iterate through all the items and say that for each of the items within this, if the item is less than 50, print it. A very simple program. So for scores in exam scores, if score is less than 50, print score. Let's run it and see. Let me see. Oh, I'm just using score instead of scores. So print scores. So you see that now it has retained the value 45. Okay, so the intuition is that we found out that okay, there is some of the scores that is actually less than 50, but we don't know them. But with the any, we have a finally that oh there is. So what are those values? 45. Let us add more. So provided we have 23, 14, maybe 9. Okay, when we run this, you see that true. What are the scores? So now we've printed it. Okay. In other ways too, we can make it more better by using a list. So that scores less than 50 equals to an empty list. Okay. So then we see that scores less than 50 dot append. Okay, scores. So that we have a list. So once we are done, we print the list. Scores underscore less than 50. Okay. All right. So you have that. So you see that how we are implementing everything that we've learned to actually solve this. Okay. Likewise, you can use less comprehension to make it much more better. So let's say scores less than 50 will be equals to this. Then we are going to say scores for scores in exam score. If scores is less than 50, okay, then let's say print scores. Simple. So you see that we use just one line of code, and then here we are using all these code to solve the problem, which values within our list exam score meet the criteria, which is less than 50. Okay, how we program in it, and that's how we solve problems. So you solve problems by asking questions. And then now that you know all these things, which tool is appropriate to help me solve the problem? So here I have two options. Either I will use this long for loop, or I'll just use a less comprehension with my for loop and my if statement, all provided on one line of code, like this. Or maybe I'm going to implement it this way. Whichever way, it is helping me to solve my problem. That is, I want to know.
Daniel, Dan,
Yes, yes, please.
let's hear me.
Yes, I can. Grace, come again. Or if your network is not helping, so you can put it in the comment section. I'll do well to check it out and then address it appropriately.
All right, all right.
Okay. So basically, that is how programming. I mean, that's how we solve problems. Okay. Okay. So that's why you need to master all those tools and know what the tools are used for. Last time I was saying that it is not necessary for you to memorize them. But once your eye sees this tool, you know that, oh, this tool does this. I can use it to do this. It's like a kitchen. You have a number of items there: blender, knife, chopping board, what again, saucepan, etc. Okay, so when you want to chop something, you not go and take a spoon. Say that I want to chop an onion. I'll take a spoon. You are using the wrong tool to do the job. So it's either it will be impossible or you are going to suffer tremendously. So as a result of that, you need to know the tools and what each of the tools does. Okay. All right. So with that said, I think we need to make progress. Let me see whether um, Grace has been able to put something there. Okay. Not yet. All right. So let's make progress. So I mean that is a way of solving the problem. No big deal. Okay. So I mean that's simple. So we also have another example over here whereby we use the any to figure out whether a condition sorry, we use the all to figure out whether um, if and only if there is all the values within the particular data structure, they are all true. So here we have glucose readings equals to these values. All above 80 equals to all reading greater than, so reading greater than 80 for reading in glucose readings. So it's more of like a less comprehensive, but we are passing this argument in an or function. So here, instead of writing a for loop and then an if statement for this, okay, a for loop and an if statement for this and assigning it to a variable, we are doing it and we are passing it as an argument within this particular function. So we say that all above 80 equals to all reading greater than 80 for reading in glucose. So in other words, say that for reading in glucose for each of the items within here, is the reading greater than 80? Okay, so here it's going to give you true or false, because you are comparing each of these values against 80. Are they greater than 80? If they are true, you see true. If they are false, you see false. Okay. All right. So once you are done and you print the all, if all of them are greater than 80, you are going to see true. But if there are some which are less than 80, you see a false. So the all statement is going to give you a false because not all the conditions that you've run or you've checked against your data set are true. Okay. All right. So once you're done and then you print it, you are going to have, I think we have to, but let me just run the first one by commenting on this. So you see that it is true. Why? When we print initially, I'm coming. Let me just take this one off. And let me make it a list, okay? Just for demonstration, though you can implement this. So we say that, okay. So we have a list here. So let's print that all validity. Okay, so you will find out that we have true, 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 true. It means that all the conditions are what? True. That is the reason why when we added the all to it, we realized that we are able to get true, because when you look at the condition, when we check this particular condition across the values here, we realize that all of them are greater than 80, returning true. So we are saying that does all the values within the data set greater than 80? It's all the values. Then once you do that, if it is true, if all of them are greater, when you use the or function, it's going to give you true. Or else, even if there is one false, it's going to give you false. So let's say, let's add one false value like 66. Oh, wait. I think if it is true, if all of them are greater, when you use the or function, it's going to give you true. Or else, even if there is one false, it's going to give you false. So let's say, let's add one false value like 66. Oh, wait. I think I have a problem with my notebook. Let me just refresh it and then I'll get back. Oh, sorry. Please, sorry. It looks like my kernel is off. Okay, so unless I turn it on, so give me a moment. Let me turn my kernel on and then um, I'll get back to you. But as I go to do that, please, if you have any question too, you can ask me. Okay. All right. So I think it's back now. All right. So please, if you have any question, but it looks like you are not interacting at all, and it makes it um, I don't know, but it doesn't make it more better for me if I don't get the feedback. Okay. I don't know, maybe you are not at places that you might be able to check, but you can still indicate that here for me so that I will get to know your condition. Okay. But if you don't talk, um, it assumes that one, maybe you are not listening or you are not interested. But I think these things are also good. Okay. All right. So I think that is for the all. So once you run, it's going to give you true, true, true. And then once you run, it's going to tell you that it is true because the condition is actually true. All right, so let me uncomment these and then let's see. Okay, so this one, we're also checking for another condition. Are the readings here greater than 100? For all the readings, so this says that for all the readings here, is any of the reading greater than 100? If that is the case, we are running the or function on it so that if all of them are greater than 100, it's going to give us true. All right, so you see that we have the false over here. And what the false implies is that not all the values within here are greater than 100. And using the same iterative process that we did, we can figure out or print out the values that are not greater than 100 and the values that are greater than 100. So normally in data analysis, that is what you do. Okay, so you run such a command to, or such a function to get a fair knowledge of what is there, so that you don't waste your time to go and search for values greater than 100 when you don't have any knowledge whether some is there or not, some is not there. So you use the or to figure out, is there any, is all the values within this column greater than 100? Maybe that particular column, you are expecting some particular values. Okay, so like a civil engineer, maybe there is, you've collected data, or the data that you're working with, there is a particular column that the value shouldn't be more than a particular threshold. Maybe a clinical scientist, maybe the glucose level shouldn't be greater than, there shouldn't be any glucose level greater than, let's say, 180. So you want to run this particular all on that particular column to figure out that are all the values within this, the threshold, or within the range. If not, it becomes an outlier. So by this, you get to know that, oh, there is an outlier in my data, or maybe there is a mistake in the data entry, because in the data entry, I saw this particular value. And when I check for the range, I realize that some of the values are greater than what we are supposed to expect. So what can we do with it? Okay, so that's how the data scientist or the data analyst think. What can we do with it? Okay, so you come up with, okay, and then let me reduce those values, or maybe I can take them off from the data, or maybe I can replace them with another value, or maybe, so you try to come up with solutions so that you can have a full set of data that you can use it for analysis. So basically, this is what they do. And then they will tell you, they will be able to tell their bosses, or the one that they are supposed to respond to, that, oh, the data is this, the data is good, it is not good, these are the problems, these are what we found, and these are what I have done, and this is why. You get it? So you should be able to explain the data, and it's supposed to give insight. Okay. All right. So basically, that is what we do as data analysts. All right, so this one is that it's putting all together. So I think once you have the notebook, you can just run it and you'll be good. Okay, I have a simple exercise here for you, just to put your hands to something. Okay, so we have advanced slicing. I think we saw this earlier. I'm just going to go through this very quick. Okay, so we realized that the other time that if you have a list, you can slice it. We have the start and then the stop. But when you want to perform an advance, I think I even make mention of, you can have a start, stop, and then a step, where the step tells you the incremental steps, whether you have to be jumping 2 times, you have to be jumping 3 times, you have to be jumping 4 times, and so on and so forth. That becomes the step. Okay, all right. So let's see that in real action. So we have a sensor records temperature every hour for 12 hours. So maybe the person works in a very big refrigerator unit. Okay, and then the sensor records the temperature of the refrigerator. Okay, for mass storage of, let's say, fish or whatever thing. But I mean, all that I want you to do is to position, I want to position it from the aspect of a data analyst. So as a data analyst who is working in that particular company, and now you have all these data being generated by the sensor for 12 hours. Okay, and maybe you would like to say that, okay, I want to know the the temperature at interval 2 hours. At every 2 hours, I want to know the temperature. This is the implementation. So let's, if we want to slice, we just need our square bracket and provide argument. But here you see that we have two columns. Where do they come from? When you look at this particular syntax, you see that the list name, start, stop, and then step. So when you have two columns without any item here, it means that the start value starts from the beginning and the stop value ends at, and the stop value is the very end. So that is why they are empty. So while these and these are not there, you're going to get only this and that, and then your step value. That is what we are doing over here. So this and that, and then our step value, which slices the or which subsets our hourly temperature. in 2 hours at 2 hours interval. So here 0, 1. So we know that the last item is not added. So let's see it in real action. But I want to comment on this so that we see. Okay, so we have the 28. So starting from here, so 28.1. So 1, then another. So you have to jump twice. So the incremental is 2 times. So move 1 and then another one, giving you this, another one. Sorry, 1, 2, this, 1, 2, that, then 1, 2 till the last end. Okay, all right. We can also do for 3 as it's being shown over here. That's incremental. And I've told you that these 2 colons, they are not a mystery. It's just that we've not provided any value from the start and then for the stop. And you see that when no values are provided for the start and the stop, it begins from the very first and ends at the very last. Okay. All right. So that's that. So we can get the values at interval 3. So you want to know, oh, what was the temperature at 3 hours interval? It's not that now that you are going to go through. So as a data analyst, you just pick the data, you just write your code, and then you are going to. So in this case, in a tabular form, you are going to subset that table that have temperatures at interval 2. Okay, a 2 hours interval. So you have them, it's like, okay, so boss, at 2 hours interval, this and this and this was the temperature, that and that and that was the temperature. And maybe as we will be learning very soon, you like to plot to see maybe the distribution of the temperature at interval 2. Okay, all right. Or maybe you like to do a scatter plot. Okay, maybe the 2 hours against 3 hours to see how the temperature varies based on hours. And it's so wonderful, and that is what we are doing. Okay, so I think we have something like that. So it's just simple. This one we have a starting point, an ending point, and then a step. But when these two, the starting, the 2 and the 8 are not provided, they will be empty. So you have 2 of the columns. Okay. So this one starts from 2. So the item 0, 1, 2, that is the 65. And then it increases the incremental value or the step or the jump is 2 times. 65, 1, 2, 75, 1, 2, till the 8th item. And we know that always the 8th item is not added. So possibly to the 7th item because Python use a zero-based indexing. That is, it starts counting from 0. So basically, that is what that is also about. Okay, so with that said, I think we can make progress. So we can have a negative reverse, a negative, a reverse stepping. Okay, when we want to do the reverse stepping, we use a negative value. So it means that the jumping will start from the last value, and in that reverse order. Okay, so let's do that. So it kind of reverses it because it starts the incremental from the last value and then from that order. Okay, so let's see. So we are starting from the fifth value and then to the first value. So the fifth value is 0, 1, 2, 3, 4, 5. So the fifth value is this one. So we are starting from 8 to the first value. Sorry, to the first value, which is 0, 1, which is the 60. And then the incremental is we are counting it backward. So 80 negative, when you move a -1 step, and we can even change it to 2. When you change it to 2, it will move 2 steps. So 80, 2 step backward, 70. Okay, right. And because it has to end with the one and this one, it is not being included because always this value, the second value, which is the stop value, is not included. Okay, so basically that's how it works. All right. So when you omit the stop, the start value, it means that start from the very end and beginning. When you add it, when you omit the stop value, it means that end it at the very last. When you do not provide it at all, it brings the entire list because it starts from the very first and end at the very last because you did not provide any starting stop value for it. And then you can also do the negative, which um, slice anything from the negative 3 position. So it's from the first very item to the item in the negative 3 position. So here negative 3, negative 1, negative 2, negative 3. Okay, but this one is not included. So possibly it's supposed to print that. Let's see, it's in real action. So it's printed this for, yeah, when we did the negative 3. Okay. All right. And then when you do the negative 3 upwards, it means that starts from the negative 3 and up. So 0, 1, so negative 1, negative 2, negative 3. So starting from 80 to the very last. All right. So that is how the slicing also is. Okay. And we can do this to tuples also because tuples also can take sliding and slicing and then with the same particular syntax. So when it comes to list, last time we saw one, you can create a list of lists whereby you have lists, these lists within a list. Okay. All right. So once you do that, the catch here is that you can retrieve each of the items of the list. And once you retrieve each of the items of the list become a list also. And so you can use all the methods that you can use on the list to get all the values that you want. Okay, so I think we have that. So list of lists, and then when you look at the length, the number of list items, you are going to get 5 because we have 1, 2, 3, 4, 5. Okay, good. So if you want to access a row, we are just using the same list, just that here we have a list of lists. So you are going to get, instead of, yeah, so when you print patient 1, so this from this data, when you print patient 1, you are going to get the first list, and negative 1, you are going to get the last list because we know that negative indexing starts counting from the last item. However, you can see that each of these indexing values return a list. And if it returns a list, then you can still perform another slicing on this list to get the individual items of the list. And so that will come to accessing a single cell. So we have the list, row index, and then the column index. So here, let me just pick up this for the sake of um, easy reference. Okay. Oh, wait. I think I've jumped to outside the zone. Okay. So here you see that we have a list. So patient 1 will give you this list. And within that list, we want to figure out the second item, the item in index 2. So 0, 1, 2, which is at 98. So this one can also be seen as a table whereby you have row and then the column. So this represents the row and these represent columns. Okay, easily get it. So it can be like a table whereby you have a list. Let's say here should be names, comma, and then here should be, I think I defined that before. Okay, so let me just copy this. Okay, so instead of typing them manually, let me copy and paste. Okay, so what are we are trying to say that assuming, okay, let me just read it properly. Distance. Yes. What? Please come again. What data? To strings. Oh, okay. So it's a shift. So it's a shift, and then the I don't know your keyboard, but no, mine is a shift, and then once. Okay, let me just try one. Okay, so this I just select it like this. Okay, and I press the shift, and then the quotation, then it converts it to string. So the shift and then the quotation mark key, yeah, the quote key, then it does. So the reason I'm doing this is to just to mimic like a table. So you have a table where you have the name. Okay, let me just add them. Sorry, the names, which are the names over here, and you have the age, which are the ages over here. You have the glucose level, which are the glucose level over here. You have the blood pressure, which are these over here. So this can be a table, and it is actually a table. So in this table, you have rows, 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 and then you have columns. Okay, the columns, I cannot do that, but I'm just going to show you. So follow the mouse. So we have the columns, columns over here, columns over here, and then columns over here. But so provided we want to extract the value of the first row, so we are omitting this. I'm assuming these are the title, okay, the headers of the table. So we want to extract this. What you have to do, this is a list actually. So we are going to say patient index 1. So it will return this particular row, the values on this row. But if we want to find the values on row 1 and column 1, row 1 and column 1, we are going to say patient index row 1 and then the column. This is column 1. If we want to do column 2. So it's the same thing that we are doing over here. Please, you get it? So patient, what do we want? We want the glucose level, the glucose level of the patient in column in row 1. So the glucose level of patient in row 1. And the reason why it is 2 is because when you look at it, 0, 1, 2, the glucose is at index position 2. So that's why we put the 2 there. Please, I hope we understand. Please, do we understand?
Yeah.
Okay. All right. So what I'm trying to say is that
Um.
okay. So what I'm trying to say is that with this particular list of lists, okay, we can consider it as a table, and I'm just using these as headers of the table, whereby we have the names, age, glucose, and then blood pressure. So imagine you are the clinical scientist, okay? The clinical scientist took some data from people, and this is the structure. Maybe you don't, this is the only data structure that you know. You don't know any data tabular, so you store them in this way. So when you store them in this way, as a list of lists, this particular um this particular individual and the items within his list becomes row. So row 1, and then row 2, row 3, row 4, and then row 5. So he took data of 5 people. So all those 5 people, these are their rows, and each of them have their items. And then if these are the rows, then the their columns will be the individual items per each particular participant of the experiment. So here, Amma Boateng, glucose age is 34, glucose is 98, blood pressure is 120. Okay, so this is row 1, and that row 1 contains the data of Amma Boateng. And those that we know data, we know that that is how we store data most often. And these becomes your columns, as in the names becomes your columns. And so under the names column, you find all those that you find the names of all the participants. Under the age column, you find the ages. Under the glucose column, you find the glucose. Under the blood pressure column, you find the blood pressure of all the participants. Now, what is next? Since we have rows and then we have columns, we can use Python and list slicing to get the items within the rows and then the columns. And here is the rationale. So if I want to get the name of the person in row one, okay, so I'm going to say patients. What is the role of the person? One. And what is the column of that person? Column zero. So here is going to be zero. So let me just use practice it so that we get it. So I'm omitting this. So this is zero. So I'm omitting it. So I'm starting from one. So row one. Okay, Amma Boateng. And then I want to get her name. And so the name column is at index position zero. So that here is going to be zero. Then when I print, I'm supposed to get Amma Boateng. You get it? If I want to get the name of the blood glucose level of the patient at row one, I'm just going to look at the column number. Okay, the column index of the glucose, it is 0, 1, 2. So here I'm just going to pass 2. And here we know that here is I'm about 8 and glucose 98. So I'm expected to have 98. Likewise, I can go, okay, I want the name of the person in row 5. Okay, so row 5, I'm just going to change the row here 5, and then the column is 0 because the names is under column 0 or is at index position 0. So you know that we have Kwesi or say. Please, do you understand it now? Hello? Please, do we get it now? So that is one way of thinking about it. Another way of also thinking about it is that when you index um, patient 5, it's going to give you a list. So let me demonstrate that one also for the sake of understanding so that whichever way we want, we can actually take. So patient 5. So what was the output? Is what? It's a list, right? Okay, if this output is a list, it's more of like you have um my underscore list equals to this. Okay, all right. So if I have my list equals to this, I can still subset the first value, isn't it? So I'm going to say my underscore list equals to um let me just say first value. First value will be equals to my list. Then we say 0 because the name, which is what I want to retrieve, is at index position what 0. When I do that, let me just print first value. What do I have? Chrissy or say, isn't it? And it is that same value that when you print this one, you are going to get. Sorry. We have Chrissy or say. So when you look at this place, is this index 5 and index 0? And here, instead of separating it like this, we've just put it together. So index 5 will give you an output. And for that output, I want the index 0. So you can also think about it that way. This is how we now understand it better. Please, do we get a concept? Good. So we have an example over here which does the same thing. So when you look at the negative, it looks like it's going to start from the last column, okay, and then the last value of that column of that particular new list that you get. All right. So you can have a list of lists you can iterate through which I believe we know. Okay, so basically, yeah, so let me just talk about that pen. We know what that pen does, but let me just elaborate so that we can. So new patient equals to epinephrine pump, comma, whatever. So patient dot append. So we are appending this new list or this new data. So imagine you are collecting the data, and as you are collecting it, you are putting it into a list. So this is the new list. So you want to add it to the patient data that you have. So what you're going to do is that the first patient dot append the new patient. So it will add this value to the list. So initially when we were doing append in list, we were using single values. Okay, but now the values within the list are actually list. So that's why you can also append this new list. But we realize that when you want to combine two different lists together, we use the extend method. All right, so once you do that and you print, you see that Abena Frimpong will be added to the list. So now the number of rows will be 6. The number of rows will be 6 because we have a new person. And you can index it using the role and then the column intuition, or you can index using that, provided that once you index a particular value, you have a list, and with that list, you can also perform another index. Okay, so that is that. So yeah, we kind of iterating. Okay, so it's iterative method. Let me see. Okay, so the reason why it is returning an error is because of this particular thing that I added, because they are not numbers. And so Python will see them as strings and cannot add them to it. So let me just comment that line. So when you get a notebook, you can uncomment it to figure it out. Okay. Let me see, list out of range. Okay. List out of range. Patient 5. Oh, I think so. Sorry. List out of range 0. Oh, sorry. So 4. Okay, good. So it's working. Okay. All right. Okay. So like say that then. Yeah, there. Okay. So we got to. Oh, sorry. Okay. So we got to this place where we're trying it then. So here we are just writing a for loop. So for I in range length patient I dot append. Okay. So BMI then values then. That's simple. So for each of the values, so for I in range, and we know that the range gives you a starting value and then an ending value, which is the last but one. Okay, so patient dot I, patient at that particular index dot append, BMI values I. Okay, all right. So once we do that, we will realize that we will add a new column to our data, which is BMI. So these are the BMI values. Okay, and we want to append it to the patient's data. Okay, so we are saying that for I in range, so the range of the values over here, patient I, meaning that so if I is 0, so this value dot append BMI values I. Okay, so patient, the patient data that we created earlier. So at position I, which is 0, we want to append that BMI value at position I, which is the 22 pointers. So you see that here it has added the 22 and that for each of the values to all the people that we have. Please, I hope we get it. Please, do we get it? Please, do we get it? Okay, okay. All right. So I think that is that. So we have list of tuples, which basically does what sorry, tuples of list of tuples. That is when you have a list of tuples. So you can perform what you can do on lists on the entire list, but with the individual tuples over here, you cannot change its values. Okay. All right. So these are to show you some of the things that we have. And because both list and tuples are indexed, you can perform a double subsetting on them to get the individual items within your list. And it has the same syntax as the list of lists. Okay. All right. And we can also slice them and also remove them, and then so you see that removing, we are using the pop method of the list. Okay, so it's remove the tuple at index 2. Just, I mean, it's just what we've learned, but kind of this one is more a bit clustered. Okay, and we know that for tuples too, you can unpack them. Okay, so here we're trying to do a bit unpacking. Okay, a bit unpacking for the patient's records. Because tuples have that property of being unpacked. Okay, all right. So here we just print the individual values because I've not run something. Okay, all right. Yeah, so it unpacks them. Where is it? Okay, okay. I think it's this place I want to go. So let's unpack it. Right. So it has unpacked it very nicely with a very clean formatting. And this particular print statement is what makes the formatting like this for you to get the ID, the name, the age, the diagnosis, and everything. All right. So I remember last week I promised you that I will explain some of these prints or formatting to you. So this actually, if you want to print something, we normally use the quotation marks, and for a variable, we don't put the variable statement in quotation marks. Okay, but however, Python also have another way. So for this one, we use the F. So before you type the items within the quotation marks, you bring an F, okay, which tells Python that you are going to format this particular thing in a particular way. And how does Python interpret it? Anything that you put in curly brackets, Python considers it as um, a variable. Okay, so instead of the previous one that we leave the variables ajar, here we put all the variables and the text in quotation marks because we don't want to type a lot of quotation marks. However, we bring this f, which is the formatting um, parameter here, to tell Python that anything that we put in curly brackets, they are actually variables. Okay, so these are the PID, everything. These are the variables that we have, and we pass them here. Age, so age, and you see that this diagnosis and age, they are not variables, so we did not put them in curly bracket, and Python considers them as ordinary strings. Please, do you get it? All right, so that is one way you can format it. And here the 20 is kind of the space that Python should leave. Okay, the space that Python should leave. So that's why you are seeing that big space over here. Okay, but when you reduce it or when you even take it off, the formatting is like this, which is not pleasant. So it's a way of just formatting it to be more better. Okay. All right. So you can do the same for age. Maybe you can give it some 5. Okay. So that you have some space there. Okay. All right. So we also have to put of layers. Yeah. I think that is that for today. I want to take you through functions a bit. So I think these ones we already know them. Please, any question before I introduce the function? I'm just going to introduce the function briefly because it's also crucial. And because I want us to start the data visualization coming Wednesday, I don't want us to push the function there so that we start the basics of data visualization. Any question on the advanced list and tuples?
Oh, Daniel, when you were explaining the
Yeah, hello Grace, come again. I didn't get what you were saying. Or if your network is bad, you can also type it. But any question? If there is no question, then I would like to open the. So Grace, I'm keeping the notebook for you. So once the question comes, then I will address it. How to use the F again? Okay. So I think the formatting, right? So this is what I'm saying. So with the formatting, so it's more of like I think this one the code is a bit messy. So let me use more precise ones. So let's say name equals to Grace. Grace, I'm just using a dummy age for you, okay? So maybe you're 23. Provided you are older than that, forgive me. Or it's too much for you to forgive me. Okay, let's say and then your height is, let's say, maybe, women are not too tall, so maybe let me give you 4.5. Okay, all right. So you would like to print the ideally we used to write like um why should I use capital letters for this age? Oh, good. Grace is 23. Let me years old. Okay, so Grace is 23 years old and her height is this. This is also a way of formatting or printing out these things, okay, seamlessly. However, using the formatting parameter, so you are going to say print, then you say F, then you do this. So in this case, I'm going to say yeah, name is then age years old and her height is height. Okay, so let me uncomment this one so that I print it too. Grace, do you see that they are the same thing? Okay, but this one has that and this one has this. So when you use the F, you put the variables in this. So you just use single um, quotation mark. But if you don't do that, you have to bring quotation marks here, another quotation mark here, and then see that there is a lot. Okay, so for convenience, why don't we use only one quotation marks and invent a way that you can type the variables in curly brackets instead? So here you have the variables in the curly brackets, which is your name,